All right, I'm gonna keep working on this PE COFF dumper or generator program that we were doing last time. And if I remember correctly, we got to a really interesting spot where I had just zeroed out a very big block of data right here, right? And everything still worked, so I can hit F1 to build my, well, that's my dumper. F1 to build my generator, F2 to run the generator, and F3. Okay, so that doesn't work. That is too bad. I thought we had tested that was working, but I guess I wasn't running the generator. I think something I need to do is I only have one of these available at a time, but maybe I should just have both. Always build the dumper and the generator because I'm working on them together a lot. That way when I run the generator on F2, run the generated program on F3, run the dumper on F4. Okay. So zeroing all of that out didn't work, which means in order to make it work, we need to go back to having this as our data. Build, run. Okay, so that works. Now what I don't know is how do I want to go about how do I want to go about figuring out what parts of the R data are optional and dealing with that? One option I have is I could. Okay. Okay, so what I could do is I could modify the R data manually, like this. Like I would go push an array onto the arena, size of R data, right? And then what I could try to do is track down the ranges inside of here that I don't think I need and zero those out. So initially, well, first of all, let's just run this. That works. What I had been doing before, I could do it a different way. I could say, there's a spot in here, our data modified plus $544, and there's another spot $1672, but that's a V off, and I need to subtract the base V off in order to get the length that I actually mean to have. So OX16720 minus OXE000. range min, range max minus range min. So I think this is what I was doing before that was not working, right? Okay, so there's an easier way to do it than what I did yesterday. But let's try to get more precise. Maybe I can zero out ranges that that are more narrow and find which things I can actually afford to zero out that way. So the exception table. What if I zero out the exception table? So the exception table, what is its range? First of all, the range of our data, the VOF, our data VOF range is OXE000 to let's see, do I have imhex up somewhere? Let's get imhex. Okay. OXE000 plus this much, 16E64. So no to this, and this. Debug info, we can definitely zero out that. So let's see. U8 range min. Our data modified. Oops. Modified plus OX15750 minus OXE000. U8 range max is range min plus 84. Memory 0, range min 84. Might as well just do this, right? Hey Voxel Riffs, good to see you. It's been pretty good. I've been up to a lot of cool stuff. Launched the lab, and you know, MrForth.com/membership. I don't think I said it at the beginning of the stream, at the beginning of the video or anything, but go check it out if you're watching and you haven't seen that before. And working on cool new stuff. How are you doing? All right, let's try zeroing out load config table. That still works. Okay, so that is everything besides base relocations and exception table. So what else is living in our data? I don't even know. I don't know what the rest of our data contains that is so critical. So our data starts with lookup table RVA, right there. Lookup table, address table, here at the beginning. DLL name. So I don't know what any of this internal stuff is, and neither does my parser. Well, some of it's like, okay, that's the debug data. What are you up to, RData? What are you up to? This is the generated EXE. Good question. I should get both of them in here, actually. They're still parallel to one another quite strongly, so we might as well have them both. We could, like, identify these ranges that are, like, have specific sort of could these be could these be UTF-16 strings right here? Because they look like pairs of characters in UTF-16 to me. It's weird how the wide string doesn't actually carry on. Security, system, functions, dialog box, API MS win core, date time, API. I don't know any of you are doing. So that's just a block from 0 to FF. Here's another one. Man, okay. So yeah, there's a lot of stuff here. Let's see if we can figure out if any of these can be wiped out and still let the thing run. Because we know we can't wipe out all of it for some reason. But maybe we can sort of zero in on which parts do actually matter. So maybe I don't know. I wish I could find any hint of what these things are coming from, so that I know if it does break what I broke. These are the easy parts. Now, actually, let me just double check something. So we run the generator. Yes. When I look at generated, and I scroll down to the table here, and I went back up a little bit, then I started finding all of these. And there's Mr. Forth, build, mini, PDB. But this is the generated EXE, so all right, let me just do the math. 15610 minus E000 7610. Add that to C600 13C10. Okay, so yeah, that part is zeroed out. Let me do the diff. That way I can tell where the changes are. $190. So yeah, here the changes are that I zeroed out all the data directories. Then farther down, 13C10. I think that's what we were just looking at. Okay, so my zeros here aren't hitting the mark. $15750 minus E000. One five seven five zero 15750 minus E000 plus C600 13D50. That's not it either. Oh, this is something. Okay, so this knows something about this section. I just don't know what it knows. I don't get it. I wish it would tell me what larger pattern it's dropping in right there. Okay, it's this thing here. It's a debug data directory. And RSDS, don't know where you're coming from, but you've got the string RSDS, the GUID, the age, and the path. Okay. Okay. Let me just make sure I know a couple of things accurately here. E000 is the virtual base. C600 is the physical base. So those are accurate. debug. Okay, so 15750. 15750 minus E000 plus C600 13D50 13D50 begins right here. Okay. So if I'm doing this correctly, D50 should be showing up right here as something that I modified. Looks like it is. Okay. So probably the load config table is this bit right here. Okay, so if I don't do that, go yes, reload it, rerun this diff. So those parts match. It's right here, 13D50. This is the part I wiped out by zeroing it out. 13D50 starts here, gives me characteristics, time, date, major version, minor, the code view, debug type, the size of the data, virtual address of raw data, the pointer of raw data. So let's look at 81616. Gives me a hex of 13ED0, which is this thing. Okay, got it. Eight 88272. 158D0. Size of 54. Okay, that still works. And now we've zeroed out rerun the generator, or the diff here. So we've now zeroed out this chunk here. Which seems to match to this chunk here. Right? So that was safe. There's still so much here in our data that could be other stuff, though. What I'm kind of doing here, because I'm guessing it's probably not super obvious, is I'm looking at these blocks and trying to figure out which ones of them are required so that I can actually then go and figure out why they're required. So let's try to just do it from another angle here. I'm going to start from, since none of this is getting marked up by the hex editor, I don't have any clues about what's significant about any of these. So let's just start with ranges that look like they go together. C820 . C900. Okay, that part was safe. Oh wait, this is wrong because I'm gonna need to subtract OXC600 to get the actual offset into the R data section. This is the base of this on the F. So this is an F off, but R data modified is not relative to the base of the file. So that doesn't work. That part is needed. Okay. Let's bring that back. And we might try saying, is it true that this part is needed separately? C8F0. So instead of going all the way out there, we go C8F0. And then we can try C8F0 to C900. C8F0, C600, C900, C8F0. Nope. So when I zero out just those F's, it messes up. So this appears to be needed, which makes me wonder, was this part still needed? Yes. Okay, they're both needed. And I don't know exactly what they are, but it doesn't like it when I remove them. They don't match this pattern. A015, A015, 30CF, 50CF. Hard to know. Hard to know what this might be. 5, 1, 1, 0, 6, 0, 3, 0, 0, 0. Done? I don't know. I don't know. What about these? These look like they have a similar structure here, but then are different here, right? I mean, this looks like a symbol table kind of thing, doesn't it? Like, if this is an offset 1C, 7C. Let's try some stuff here. 1C, 7C. Whoops, 1C, 7C. Yeah. Let's see if we can figure out who might live at 1C, 7C. where there might be a thing that's 1C, 7C. Let's start with plus C600. See if this is an offset. E2 7C. That would be right here. That doesn't look like anything. This looks like a language. Need to figure out what has this layout. Whatever this is. We just keep finding more and more of those. So it kind of seems like, what if I started from here? 1C, okay, 1C, 7C. What if I look from the beginning of the file? I doubt it, but worth a shot. That's nothing. What if I treat 1C, 7C as a V off? Where does that land me? We'll be here in the text section, 1C, 7C. Okay, let's try that minus 1000 plus 400 107C. These are int32s inside of a disassembled block, and this is the beginning of code. So that might be a pointer into the text section that we're looking at. We might be looking at a pointer into the text section. So if I go back to the beginning of our data, so these might be the same. 15A0 minus 1000 plus 400 9A0 is in the spot in the file. It's less likely, but maybe. I mean, what would that be as an instruction? I don't know. Another question is, could I decipher this format here? So what's happening here is each of these zeros tells us that these 8 bytes represent a named import symbol. This gives us the offset as a VOFF to the name. And this right here is the end of the table. What is this? It looks like I don't know. But we end up with more names over here. Maybe if I found something that looked like that. I could also go and read this. We have a new resource on PE files. If these are, they could be flags. I want to see if there's like, is there any reference? How do they? This looks promising because it lines up with something we're seeing, but it's not quite right. What are you? A015. A015. C820 plus A15A0 DDC0. So starting from here, C820, add 1580, and you get DDC0. That's nothing. It's hard. I don't know what these things are. I know we can't erase them. So the next chunk that looks like it's all the same thing is this whole thing here. Definitely gonna guess that we can't erase it, but let's give it a shot. OXC900, OXD020, C900 minus C600, OXD020 minus OXC900. That works. You'll let me do that? We can just blop out all of that. We can't blop out any of this. We can blop out all of that. What about all of this, then? All of this up to right about here. It looks like we were getting a few more of these symbol-like things. So let's leave those untouched. But this, like, 8-byte aligned string name stuff, D020, to D6E8. Pilfers, yeah, I'm still using Imhex. It's helped out a lot. Good recommendation. Whoops, this goes here. D020 minus OXC600. Although it does not seem to cover everything that comes up on PE, so we're still having to figure things out. But yeah, that let me zero out that whole chunk. So whatever this is critical, but this is not. And then we get 1, 2, 3 of those types of symbols. Four. 1, 2, 3, 4. Okay, so that is not cool. You don't like it if I erase that. This is gonna be hard. Tool tireless. Hey, it's going all right. It's rough because this project is tricky. I'm not sure how to. I'm not quite having a breakthrough yet. And what I'm doing is kind of interesting, but I'm kind of feeling like I'm not gonna actually figure out what to learn here. Like, some of these are very, very confusing why some things are allowed to get erased and other things are not. This feels a lot like it's more import information, but I can't figure out what it is. Maybe I should go and read. We know about directory table. We know about lookup table. It's none of those. Eric Ava says, can I ask a dumb question? Can you use an assembler for a smaller file and data to parse through? So I've tried that. I've tried using... Let me show you what happened. I'm not sure what I'm doing wrong on that front, but let's say I were to go build a mini.asm instead of a mini.c, right? And so my goal here is going to be, we're going to do like proc main np main. If I pull up another asm file and make sure I'm getting the syntax right here. It's the other way around. Proc np. We're going to move into AX A1, then we're going to return it. Do it that way. I need to end the file, and I need to give it a code directive there. We can go to build fly, and instead of building mini.c, we could build mini.asm. So here we can see it as assembling mini.asm. And what we get out of that is a mini.exe. And yes, reload it. Now I have a totally different mini.exe. But guess what? It's actually like still gigantic. It's 94 kilobytes just from running the assembler. So in order to actually get it to not be so big, I'd have to like dig into why it's still doing so much extra work. This is the wrong one. Give me the real local vars. Yeah, I want to turn on diagnostics. That way I can see ML64. Here's how we're running it. So that's debug info right there. Let's take that out and let's just run that on this. We'll do that, except this needs to get renamed to C:// There we go. Now if I delete everything called mini in this directory, and I do that command again, and then I list out everything called mini, we have a mini.obj, and it's super small, 420 bytes. But it's not an executable yet. What if I were to say, do it like this? Unresolved external symbol main CRT startup. So you see, I'm not sure what I can actually do to make it. If I do it this, it says unresolved external symbol main CRT startup. But I can't just rename my main because then it also looks for a main. If I go to my local VARs and turn on diagnostics and run this again, in addition to looking at how I run the assembler, I can look at how I run link. Here's link, mini exe, no logo, default lib, libcmt, optref, incremental no, debug, machine. Let's take out debug. Let's take out all the libs. Default lib might still be an issue, but let's try this. So let's try, we'll delete all the mini stuff. We'll run this. Oh, whoops, gotta fix the file path here. So this is gonna be C: with backslashes. So there's mini.obj, 420 bytes. And then link, mini exe, libcmt, boom, dir mini, and 95k for mini.exe again, right? So how would I make it not do that? I'd have to go in and figure out what to do about the default lib on the linker. No default lib. Let's try it. Right, so what if I did this? And then it's like unresolved external simple main CRT startup. So I feel like I have to go and learn how to eliminate CRT to get the benefit that we're looking for of shrinking the executable size down. Okay, Valbus, I'll show you what we tried earlier, which is I was like, okay, well, if it wants main CRT startup, we'll just make that my entry point. And then we'll delete all the mini stuff, run the assembler, run the linker, and now it's saying the entry point must be defined. So it's not clear what's happening to me. Okay, so we could define a function that specifies a user-defined starting address for an EXE or file. Let's look at what subsystem we're using, because I don't think it's listed, but maybe there's a default. Specify the Windows subsystem by the executable boot application. An application that runs Windows boot environment from about boot 132 The operating system provides a console if main or wmain is defined for native. Console is the default. Okay, so we're in console mode, which means it's looking for this as the function name for the entry point, and calls main or win main. So if I just said entry is main, would that trick it? Because then it would see that I have a main and also use that main as the entry point. That might have done the trick. Mini. Okay, now we have a 1 kilobyte mini EXE. Does mini run? That's the next question. Mini does run. Okay. That's going to change things for us. That's going to completely change things for us. Yes, we want this. We want to completely ignore what we've been doing with generated. We're going to start with mini.exe again. Yeah, okay. So from the beginning here, what do we got? Section table has 5 sections still for mini. Is that true? Can we make sure it's like redone the parse actually? Let's open mini exe. Yes, grab hex. Okay, so 2 sections. We have an R data and a text. Our text section is tiny. Our R data section is tiny. All right, we're in good shape. We're in good shape. That's going to change everything. Let's just start from scratch on deductions here. Let's go over to the data stuff here. We're just going to wipe out all of this is gone. Let's start with mini.exe. Why is there we go. So this thing just came out with the smallest header I've seen yet. Clocking in at A8. 168 bytes. Cool. Yeah, copy as C array is really cool. I wish it. I wish I could go a little farther, but I always wish that. All right, I can turn diagnostics back off. We're kind of back into a whole new flow here. So we got a header. We put the PE signature right after the header. Wait, why did I think that was the whole thing? This says the PE signature. Oh yeah, that's right. That's the signature. No, this says the PE signature is right here. Did I skip some? Seems like I did. But then again, I might need this thing to rerun. There we go. That's more like it. Okay, so never mind. We do need a bigger chunk than I thought. Copy as C array. $256. Okay. So that's a part of the header. Why is that different? I just copied the entire header, including this part. Oh, I'm not rebuilding. Right. Here's how we built our mini in the end. And then we want these back. All these other sections are out, out, out. Out, 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 out. Section count is 2 now. Okay, so now it can't run, but we're not quite done making it work yet. So let's look at the diff. Generated EXE, that's all fine. What's the difference here? Thought for sure we had squared this away. This whole thing. I don't get it. I don't get it. Why is it so off? Thought we just had this all straightened out, and now it's back here. I must have accidentally rebuilt mini the wrong way. So now we have a small header again. C array. Okay. So hopefully we can start zeroing in on matching these without getting so off. Yes, reload it. Run the diff again. B is the first difference. That's our timestamp. C, that's our linker version. Size of code. It says 512 here. Let me make sure this is updating. It says 6 here. So I think what's happening so this must be doing like an align up. And since we're using .512 as the file alignment, we get something like that. That's the linker version. What is this 2 here? That's in C9. So this is going to be the same thing again with the R data. So those agree now. What is, okay, 1 disagreement, 2 disagreements, 3rd disagreement. That makes sense. We don't have all that extra code in the system now. Okay. F, size of image. So this is going to be wherever our location is for the R data's RVA plus a line up of the size of our data 4K. I think that's the right idea. Okay, those match. What about, whoops. What about this? What is that? That is the FD byte. FD. Size of headers. So mini saying 512. Generator saying 1024. Okay. I'm just going to hard code that. Postman, the program I'm looking at is a hex editor called imhex. It's free. You should totally check it out. If you're into file format hacking, it's been pretty helpful. Okay, so our next disagreement is right here, FD. Okay, I thought I just fixed this one. F1, F2, yes, reload it. Redo the diff. Our next disagreement is here. What is this? 106. So Mini has dynamic base and high entropy VA. I have generated has high entropy VA but no dynamic base. Okay. That should help. Yes. Generated. Number of RVAs and sizes, 0. So this one here, that's the imports. And we are now saying that that can be a 0, I guess. All of these saved ones are from when we were emulating the big fat mini.exe, which we don't need anymore. So I guess we just have all of them as 0s. Still can't run. One, 6, 1. Okay. Okay. So which one is that? COFF header in mini 161 is not empty. Optional header, directories. One of you is not empty. Here we go, number 6. Zero, 1, 2, 3, 4, 5, 6. Okay, so we can actually leave that empty. We don't need it, but it must be pointing at the very beginning of the R data section and saying that there's a debug directory there. Yeah, and we do in fact see Some debug data here. What it's some unknown debug type though. So let's start with just the ruthless approach where we say, all right, we want to match this. So here's 8, 9, 10 times 2. Wait, this is saying 2, 0, 0, 0 is the V off. Right, I don't know what I was thinking. Right. Right. And this is 28. Make the match. All right. Let's go into the text section. Just go to the beginning of the text section. Copy. Copy as C array. Copy that as a C array as well. Still doesn't run. All right, well, how far off are we from matching the exact layout? Okay, we still have some issues. What is this spot? 1B8. The section table doesn't line up just right. Okay, let's look at our section table here. Text, virtual size. Okay, what's that difference? Mine is short by 16 bytes. 4, 8, 12, 16. Still doesn't run. Force in some zero padding. There we go. Okay. All right, so now we've got a very nice minimal executable. I want to push it even farther and see if it'll go all the way down to basically 0. One section. Like this. That works. Amazing. Can delete this file. Come up here and drop this in like this. Get rid of you. Amazing. Excellent. No longer interested in diffing these or using you. We have built an EXE called generated EXE, containing exactly 1 kilobyte of data, and all it does is return a 1 like this out of its entry point. So not a lot, but it comes out of this whole thing here. So now that I have a minimal starting point, what I can do from here is start to add in features. I can start to say, what if I did want to link to the kernel 32 DLL? Could I add in an imports table and an import address table that would let me link in a kernel 32 function? And if I did have the ability to put that import in there, could I actually get the patch up to work? Could I figure out how to call that kernel 32 function that I imported? Could I take a series of code and data that I need to put into an executable and line it up into this thing? Could I export symbols from it? Could I link in the debug information properly? These are the next big steps to making the file generator good. But there's a couple other things I want to be able to do. Now I can dump this, and I can see what a very empty looking file looks like when it's in shape that it can actually run. Oh, cool. And I need to be able to start building diagnostics that say, hey, I've tested out things that the system is sensitive to, and I have noticed that you have a problem here. So for instance, for starters, let's say I were to go and play with file alignment here. That works. That doesn't work. Right. As expected. Okay. What if I don't pad out the file like I'm doing here? Then it doesn't work. Right. Because the f-off size here, this can't just be size of text. Oh, it can be. And then you still work? Interesting. Interesting, interesting, interesting. But this can't be bigger than what goes inside the file, right? If I do this, it shouldn't work because it'll go outside the range of the file, right? And if I did this, and then I added one padding byte here, then we work again. Yeah, makes sense. Okay, so I'm starting to comprehend the rules of the game. It's not going to accept anything where the section that needs to get loaded is not actually contained within the file properly, but it doesn't actually throw up if the f size isn't correctly aligned, even though it probably should or says it would. in the documentation. Similarly, the file align can't be less than 512, or if it's going to be less than 512, we need to lay things out more carefully or something like that. Yeah. So many things. Okay. This is done. I'm just kind of plotting out a bunch of new steps for the project. We kind of have our breakthrough now. We're at the right starting point. So I don't know what we'll do today after this. This might just be, I might end a little before 2 hours, which is a little short for me. But the next big step is to take on a whole new step, right? We're at the end of an arc, or at the end of a problem here. So the arc is going to have to move on to some new problem. The structured constructors we want is to send down things like section data. We want to be able to send down loosely arranged section data. Automatically arrange header v-offs and sizes. Loosely structured exports, imports, debug, good start. PE COFF generator deal with the get kernel 32 DLL imports working, get C runtime imports working. Relocations we need to be able to figure out. Generate relocations. Generate exception tables. That's very nice of you to say. Fear of code. Yeah, I learned how to do coding like this by being on a debugger project for 5 years and having to do it over and over again, investigating system APIs, investigating file formats, picking apart stack unwinding processes and exception handling processes, and at some point you realize it's like it can't hurt you. All it can do is take time, and honestly, it takes less time if you just keep diving in. And so I have enough experience here to kind of know what I'm looking out for, which helps. But you still kind of on the point there that like it's very easy to get afraid of how finicky and raw all this stuff is. But if we get our hands on it, if we really get a handle on this low level stuff and figure out what's happening and what we need to do to keep control over it, we're going to be able to do way more than what we can do right now. So I'm hoping it'll pay off. It will actually succeed at tracking all this down piece by piece. But I think this is a good to-do list for now. Where I'm at is we have this generator working now. We got a minimal starting point, and so I want to start. There's the PE-COFF generator part. The dumper was good to go. There's the PE-COFF diagnostics tool that I want. That's this part. And here we're going to want things like PE-COFF visualization. We're going to want things like PE-COFF error, format error, feedback. We're going to start trying to build a tool here, and I kind of want to think through. There's this abstract notion. Do I want to match Windows level of pickiness? Say the Windows loader looks at my file and says, yeah, I'll load that and I'll run it. Do I want to make my thing say, okay, that's permissible too for my tools? Or do I want to make my tools more narrow? Do I want to make a narrow, do I want to accept like, hey, there might be cases where the Windows system actually isn't as picky as my system. And if you find those, great, good for you. But my system is trying to ensure that your thing will run. And so it might go overly narrow just to be sure that it'll run, right? Like, for instance, the docs say that file align here should be the alignment used for the F-offs here. It doesn't necessarily say that the F size should be a multiple file align, but it turns out that that kind of makes sense as a thing to do if you want. So I could, like, the generators they have seem to generate stuff with this shape, but their parser doesn't require that. So I have to decide if I want to be as loose and forgiving as Windows, or if I want to say, hey, I'm not going to be able to track down every little corner case. I'm trying to help you make an executable that works with as little cruft as possible, so I'm going to guide you towards my subset of executables that it work. That would definitely be easier, the second option. Less investigating. And I don't know what the benefit is to having all the corner cases exactly match Windows, if Windows can change from operating system 11 to 12 or whatever. Like, what's the point that I figured out one of the cases that works? I'd rather find a subset of all cases that work on as many of the versions of the operating system as possible. But on the other hand, saying something is an error when it might actually work would be confusing and possibly frustrating to anyone who's taking advantage of those affordances of the operating system. So I got to think about that. And I got to think about that for both this side and this side. Do I want my structure generator to be able to generate every possible EXE, or just the ones within my strike zone? And do I want my feedback system similar to give feedback that is as tight, that is extra tight, or that, like, matches more closely to what Windows can do. Mapping raw data ranges to purposes. Table views. And then, of course, another thing we still need to do is we need to get deeper into, there's the next step after this. If I've got a generator and I've got a diagnostics tool, then there's PE, COFF, linker we need to start thinking about. Put object files together into an execute image file, right? That's a thing that we want to be able to do. Maybe a little later down the road still, as we are still exploring our options here. We want an image generator, image diagnostics tool, and later we might also want, in addition to all of that, an object generator and an object diagnostics tool. And then, of course, there's the elephant in the room for someday. There's also debug information. Okay. I think that'll be where I sign off for today. I've got a big, long path ahead for this project now. Not really sure where we're going to pick up next week, but we did a lot today. We hit a good milestone and did some plotting for the future. And if you're inspired by this kind of work and you'd like me to be able to keep doing it and putting this stuff out there and eventually turn this into some useful tools, do think about going to mrforth.com and becoming a member or a supporter. I am counting on anyone who can to pitch in to keep this sort of stuff going, and I really appreciate it whenever you do. With that, I will sign off, and I'll see you around the internet. Bye.